All right, I want to take the derivative of the square root function. Actually, I already know how to take the derivative of the square root function, but I want to look at it from the point of view of knowing the derivative of its inverse. I know how to take the derivative of x squared, and I know about derivatives of inverse functions. Right? So the derivative of x squared is 2x. Let's see how that applies here. So I've got y equals x squared. I'm going to square both sides. And the square root of x squared is just x. So I've got y squared equals x. So I started off with y as some function of x. Now I have x as that inverse function of y. I'm going to implicitly differentiate. I like the right-hand side. I can do that one. It's easy. The derivative of x with respect to x is 1. The derivative of y squared with respect to x? Well, the derivative of y squared with respect to y would be 2y, but I don't want it with respect to y. I want it with respect to x. So the chain rule says multiply by dy dx. Solving for dy dx, I get this. And of course, I pause right here to ponder the import of this statement. Up here I have that the derivative of x squared with respect to x is 2x. Now I have the derivative of the square root of x is 1 over 2y, because the derivative of this inverse function is the reciprocal of the derivative of the function with the other variable plugged in. This is, however, a completely unsatisfactory answer. I didn't start implicitly. No, sirree, I started explicitly. So I want my answer to be in terms of x, not in terms of y. Well, do I have a relationship between x and y? Of course I do. That's what I started with, and then I rewrote it another way. But here I have that y is equal to the square root of x. So let's just plug that in. This is 1 over 2 times the square root of x, which is exactly what we saw the derivative of the square root of x to be in an earlier demonstration. This inverse function thing works for so many situations. The derivative of the inverse function is the reciprocal of the derivative of the function with the other variable plugged in.